Good morning students. Today we will discuss about Brillouin zones or EK diagram. The diagram between energy E and wave vector K or Brillouin zones. What are Brillouin zones? So see here the permitted values of K means wave vector values K in 1 dimension, 2 dimension and 3 dimension are called as Brillouin zones. Now we know from band theory of solids electron will be moving in a periodic potential. So when electron will be moving in a periodic potential, they have energy values between allowed energy bands. Means energy spectrum consists of both allowed bands and forbidden bands. Allowed bands will be separated from forbidden bands. Now with the help of Kronig-Penney expression. So Kronig-Penney got an expression as P sin alpha A by alpha A plus cos Ka is equal to cos alpha A is equal to cos Ka. So this is the expression we got from Kronig-Penney model. From this expression, when we draw a graph between LHS of this equation with respect to alpha A, the energy spectrum consists of both allowed bands and forbidden bands. So like that only, if we draw a graph between total energy of electron versus wave number or wave vector K, then the graph is shown in the figure. So see here K, the value of K is plus or minus. From Bloch theorem we have derived K is equal to plus or minus n pi by A. So with respect to K, if we draw the energy n pi by A, if I take n is equal to 1, pi by A minus pi by A, n is equal to 2, 2 pi by A minus 2 pi by A, 3 minus 3 pi by A, 3 pi by A with respect to energy. So energy spectrum consists of, see here, it consists of forbidden bands. So these are the forbidden bands which are separated by allowed bands. Again forbidden band. Again this is another forbidden band. Okay. Now these are the allowed bands. These are the allowed bands. Next, these are the gaps between allowed bands which are called as forbidden gap band. Okay. Now see here. Here when we see the energy, here energy is continuous from minus pi by A to pi by A. Energy is continuous from minus pi by A to pi by A. Again there is a discontinuity. Discontinuity occurs at K is equal to plus or minus pi by A. So here discontinuity I am getting at K is equal to plus or minus pi by A, and it is continuous from minus pi by A to pi by A. So this I call it as first Brillouin zone. This is called as first Brillouin zone. Next, after discontinuity, after K is equal to pi by A, again there is continuity in the energy. So energy is continuous from, see here energy is continuous from minus 2 pi by A to minus pi by A. Minus 2 pi by A to pi by A. And this side it is continuous from pi by A to 2 pi by A. So the zone extended from minus 2 pi by A to minus pi by A and pi by A to 2 pi by A is called as second Brillouin zone. This is called as second Brillouin zone. Again there is discontinuity at, see here, if you see this, again there is a discontinuity. Here discontinuity at K is equal to plus or minus 2 pi by A. So at every K is equal to plus or minus n pi by A, there will be a discontinuity. So like this we can divide zones into zones that we call it as Brillouin zones. Okay. So see here what we have discussed. See here from graph it is clear that the allowed energy region zone extended from minus pi by A to plus pi by A, that is called as first Brillouin zone. So here it is the zone extended from minus pi by A to pi by A is called as first Brillouin zone. After a break in energy. So when we got the break in energy, k is equal to plus or minus pi by a. At k is equal to plus or minus pi by a, there is discontinuity. Again, it is continuous from minus 2 pi by a to minus pi by a. And it is continuous from pi by a to 2 pi by a. This is called as second Brillouin zone. Okay, similarly, we can get other zones also. So, always discontinuity occurs at k is equal to plus or minus n pi by a. So, this is about Brillouin zones. Now, what is the shape of the EK curve? See here, if I see the shape of the EK curve, the shape of the EK curve is a parabola. So, this is about Brillouin zones. Thank you.